Mind-blowing facts about space happening right now. Just like lavas explode and waters flow, have you ever wondered what process happens in space? For years, space has been an unknown territory to man. Since 1957, from the launch of the first satellite and the 2021 launch of James Webb, we have discovered some terrifying and shocking facts about space. Some of them are too unbelievable to be true. In this video, we will share the most astounding facts about space that are currently happening. From the formation of stars to seismic activities on the moon, we have gathered facts you have never heard before. So let's start. The moon is getting farther away every year. The Earth is being pulled toward the moon, giving our planet a faintly egg-shaped form. Water is even more affected by it, leading to the formation of tides and the oceans piling up toward one side of the Earth, or tidal bulge. The moon drags this bulge around with it as it revolves. The bulge travels ahead of the moon's orbital position because the Earth rotates more quickly than the moon. As the moon pulls back on Earth, thereby attempting to slow it down, as a result, over time, the Earth's rotation rate steadily decreases. The dragging between the two bodies results in energy loss for the Earth, while the moon gains for the Earth as they interact through gravity. The moon is steadily drifting outward due to the energy boost, relocating away from us at a rate of 3.8 centimeters per year, or roughly the same rate at which our fingernails grow. The moon keeps the Earth from slowing down to the point that it becomes unstable. Days were 5 hours long on the early Earth when the moon was still forming. But after 4.5 billion years of the moon's braking influence on the Earth, days have slowed down to the 24-hour length we are accustomed to today, and they will continue to do so in the future. We can determine how many days there were in a year in the past by examining the coral's daily growth bands, and from this, we may conclude that the number of days has been increasing at a rate of 19 hours every 4.5 billion years. The heat from the Big Bang is still around today. A boiling soup of ionized gas, resembling an invisible plasma, made up the early universe. This gas cooled to the point where atoms could form at about 380,000 years after the Big Bang. The cosmic microwave background is a type of radiation that has been around since the Big Bang. Although it is invisible to the naked eye, numerous missions over the years, including the WMAP mission and the ESA's Planck satellite, have been able to examine it in a microwave light. NASA claims that the CMB fills the entire universe and that before cable TV, any home with television could view the Big Bang's afterglow. You might view the CMB as a static signal on the television by switching to an in-between channel. By doing this, we are looking back in the time to 380,000 years after the Big Bang, right when the universe was just radioactive particles. How cool is that? There is a supermassive black hole at the heart of every galaxy. Frequently active galaxies emit 100 times as much light as normal galaxies. With the discovery of quasars in 1963, it became abundantly evident that light originates from a core region smaller than the solar system rather than from the stars. This gave rise to speculation that a massive black hole, never seen before, resides at the galactic center of our galaxy. The object, known as Sagittarius A, has an astounding mass that is 4 million times that of the Sun. A central black hole can be found in almost every galaxy, including our own Milky Way. It's an interesting fact that these black holes consume dead star materials and neighboring asteroids as they grow. What are they doing in the centers of galaxies? Were these the initial galaxies that formed around them? Or did they originate from young galaxies? These still rank among the most important unanswered issues in astrophysics. The thing to worry about is that these black holes are engulfing nearby small asteroids and dying stars and are getting bigger. Earth is under protection from cosmic rays. About 100 AU units away from the Earth, we have a whole new region of magnetic field. The magnetic field of this object is 100 times greater than the magnetic field of our solar system. But not to worry. Our sun emits rays of radiation called solar winds. The area to which solar winds blow is called the heliosphere. The space after that is known as interstellar space. The in-between region has bubble-like protection called helipause. This shield is elliptical, bending towards our solar system due to the strong magnetic effect of interstellar space. Beyond that, there are billions of stars and galaxies. So how do we know about it? NASA's two probe Voyagers 1 and 2 entered interstellar space in 2018. With data collected from them, scientists revealed that interstellar space is made from gaseous ion particles or plasma. Some magnetic rays from interstellar space cross the helipause and come to the helisphere, but their effect is negligible. However, if something happens to the helipause, because of the massive increase in cosmic rays entering the solar system, the amount of high-energy cosmic rays that could reach Earth's surface may fluctuate. Cosmic rays have the potential to harm the ozone layer of the Earth and alter DNA. The Moon is seismically active. On the Moon's surface, seismometers were positioned as a part of the Apollo space program. There were 28 moonquakes of varying magnitudes while they were actively documenting lunar seismic activity before they were deactivated in the late 1970s. Later investigations using the Lunar Research Orbiter revealed fault lines in the Moon that are younger than 50 million years old, as well as the shifting boulders across the surface, all of which indicate the occurrence of frequent moonquakes. Moonquakes can last for a long time, unlike earthquakes, which typically only last approximately 30 seconds on average. These brief shocks, which last up to 10 minutes, start between 12 and 19 kilometers below the lunar surface. Even though they are unsure of the origin of these protracted quakes, scientists have been able to learn more about the earthly seismic activity, as well as the role of liquid water plays in reducing the vibrations of quakes on our planet. A large body of water is floating in space. In the early days of space exploration, it was extremely difficult to locate water, and scientists thought there was none up there. The study has evolved, though. The oldest and largest known reservoir of water was found floating across space in 2011. According to scientists, the amount of water is equal to 140 trillion times the total amount of water in the oceans, and it could supply 20,000 times as much water to every individual on Earth. Given that space is typically thought of as a barren and dry environment, this is an almost inconceivable amount of water. The water was found near a quasar, a massive black hole that is currently consuming matter and ejecting vast amounts of energy. Atoms of hydrogen and oxygen are knocked together by energy waves to form water. Given that this was discovered at a distance of 12 billion light-years, it was probably happening at the beginning of the universe. It is so enormous that 20,000 bodies of water, each the size of Earth, might be distributed to every person on Earth. The Andromeda Galaxy is waiting for the Sun. According to NASA astronomers, the massive collision of our Milky Way galaxy with the nearby Andromeda Galaxy is the next significant cosmic event that will affect our galaxy, sun, and solar system. 4 billion years from now, during the anticipated collision, the Milky Way is expected to undergo a significant transformation. The Sun will probably be hurled into a different part of our galaxy, but there is no threat to the Earth or the solar system. The answer was discovered by meticulous measurements of the motion of Andromeda, also known as M31, made by the NASA Hubble Space Telescope. Despite being 2.5 million light-years away from the Milky Way, the galaxy is relentlessly drifting in its direction due to the gravitational attraction between the two galaxies, as well as the unseen dark matter that surrounds them both. The situation is similar to a batter viewing an incoming fastball in baseball. Despite Andromeda's more than 2,000-fold quicker approach, it will be 4 billion years before the strike occurs. It will take the interacting galaxies another 2 billion years after the encounter to fully merge under the pull of gravity and reshape into a single elliptical galaxy similar to the kind frequently found in the local universe, according to computer calculations based on Hubble observations. This ends the video for today. We have gathered so much data on the universe that it is impossible to gather it all in a small video. Share your mind-blowing facts with us. Like, share, and subscribe to the channel to find out more.